Hello, everybody. Welcome. Today we are going to be talking about something awesome, something critical, something vital. Dare I say, fun? We are talking about the fundamental theorem of algebra. Now, just to let you know, when it says that it's fundamental, what this means is we're talking about something that's the foundation of algebra, of the class that we're talking about. Now, this is one of two lessons that will cover the fundamental theorem of algebra. So first, the fundamental theorem of algebra. What does it state? Officially, it says that if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. Now, that is a lot of very official sounding math speak. So, in addition, we know that if f of x is a polynomial of degree n, where n is greater than 0, so that's kind of a repeat, then the equation f of x equals 0 has exactly n solutions if we count repeated solutions. Okay, so that is, again, a lot of fancy math speak. What is the translation of this? Well, f of x is a polynomial of degree n. What that basically is saying is that if we have a polynomial which, if you don't remember what a polynomial is, that basically means we're talking about an equation with a bunch of terms. Or maybe one term. I mean, really, it could be anything. For example, a polynomial could be just f of x equals 2x. That's a polynomial. F of x equals negative 3x to the 5th minus 2x squared plus 5. That's a polynomial too. There's a lot of different polynomials. So if we have something like this, something like one of these polynomial situations, as long as it has an exponent, that's really what degree n, where n is greater than 0, means. This just basically means that we have, this right here, means we have an exponent. Because if it was 0, then we wouldn't have any exponents. We wouldn't have any x's, actually, or variables for that matter. Then the equation has at least one solution. What does that mean? If we have a polynomial, then it being the polynomial, has at least one solution, and at most the same number of solutions as its degree. So at most, the degree equals the number of solutions. And in truth, on some level, you guys probably already knew that. For example, what this is saying is that if you know you have an equation like f of x equals x squared plus 5x plus 4, and you know that the degree equals 2, then you know there are two solutions. In these these polynomials I made up here, this is 2x to the first. That would have one solution. This is fx equals negative 3x to the 5th. That would have 5 potential solutions. Now, here's the deal. When it says at most, what that means is it's possible that we might not have 5. So here's where this other part on this page is coming into play. If one of the roots is imaginary, so if it looks like a plus bi, then it will also have a root a minus bi. Those are called conjugate pairs, and we went over that earlier. Conjugate pairs. So for example, if you had something like 3 plus 5i, then you would know you have 3 minus 5i as a root as well. Same thing with something that's irrational. If you have one root that looks like a plus the square root of b, then you're going to have a minus the square root of b. So again, I'm just going to kind of make up some numbers. I would say that if you have 2 plus the square root of 3, let's just say that, then you would also have 2 minus the square root of 3. And if you're wondering why that is, why is it that imaginary and irrational roots always come in pairs? Well, it has to do with the quadratic formula. Plus or minus the square root of b squared minus 4ac all over 2 times a. It's because of this part right here. The plus or minus square root aspect. Okay? How do we get imaginary? Well, imaginary answers come from the square root of -1. Well, you can't have a square root unless you are taking the square root of something. So that could happen. And in that case, you have a positive and a negative square root of that I situation. So that's why we have conjugate pairs with imaginary. And then irrational, well, irrationals are, generally speaking, complex answers that have a radical. Again, your square root is a plus and a minus, a positive and a negative. All right, so moving forward, we're going to take a look at some problems. Now, I'm going to do this first problem for you, and then I am going to give you some time to try some of the other ones. So, first question says, how many solutions are there? And I'm just going to remind you that whenever you're asked for that, you want to look at the degree of your polynomial. So in this case, our degree is 3. So how many solutions could there be? There could be 3 solutions. Could there be imaginary roots? Sure, that's possible. So we're going to put a maybe. But remember, imaginary roots come in pairs. And a pair would mean 2. So the possible combinations for this problem that has 3 solutions. Option A, you could have 3 real solutions because the degree is 3. Option B is that you could have 2 imaginary because it has to come in pairs. So if 2 of them are imaginary and you have to have a total of 3, then that would mean you'd have 1 real. Okay? So I'd like you to try each problem, and as you go, kind of pause and come back and try them and see if you get your number of solutions, imaginary, and possible combinations correct. Okay? All right, so taking a look at the next one, it has a degree of 4, so there could be 4 solutions. Could there be some imaginary roots? Maybe, we don't know. So what are our options? Well, the 4 solutions we have could be real. The 4 of them could all be imaginary because you could have 2 and 2. Or you could have 2 that are real and 2 that are imaginary. Remember that your list should always add up to the total solutions. So like I said before, we could have 4, we could have 4, or we could have 2 of each. All right, because that would add up to 4. All right, pause the video again and try this next problem. All right. All right, next one has a degree of 2. So again, maybe there could be some imaginary. And because there's only 2, either both of them are going to be real, or because the imaginaries have to come in pairs, both of those 2 are going to be imaginary. All right, pause before you check on the next one. All right, now the next one, it has a degree that's kind of hiding here. It's a 1, okay? So that degree is 1, and I'm going to give you just a little heads up that the 1 at the bottom has a degree of 5, okay? So here's the deal. The x plus 7 equation, that one, that has a degree of 1 does not have 2 possible zeros, which means there's no way that you could have anything imaginary because imaginaries have to come in pairs. So there has to be a minimum of 2, a degree of 2 in order for something to be imaginary. So the only option for this one, this fourth one, is that there's one real solution. And last but not least, with a degree of 5, yes, there maybe could be imaginary because that's bigger than 5. So you could have 5 real, 2 imaginary, and 3 real, or 4 imaginary, and 1 real. So here's the deal. If the degree is greater than 2 or equal to 2, there could be imaginary. I am so sorry. This is not writing very well down here at the bottom of my screen. There could be imaginary solutions. All right. So we're going to run through these last few problems pretty quickly. One of them's a graph. So this graph that you've got here is of a 5th degree polynomial. So that means it could have 5 x-intercepts. So how many real zeros does this polynomial have? Well, it could have 5. But how many do I see? I see in my picture 1, 2, 3. So that means it has, in actuality, there are 3 real zeros. So if I want to know how many imaginary zeros I have, I'm just going to subtract 5 minus 3. So imaginary would be 5 minus 3, which means there's going to be 2 imaginary. By the way, I keep abbreviating the word imaginary as IMAG. I hope that that's okay, everybody. 3 real, 2 imaginary. If you knew the equation, of the polynomial, how would you go about finding all the zeros? So if I wanted to know those specific ones, well, do you see these 3 that you can see? For example, this one that's at 7 and this one that's at 1. You would use synthetic division most likely first to divide those out. And then you might be able to figure this one out. Otherwise, you might need to use factoring or the quadratic formula to find out the specific numbers of the imaginary ones that you don't know. And we're going to talk through something like that with our next and final problem of the day. So if you take a look at this polynomial right here. So the first thing I notice is that we've got 4 terms. And so whenever we have 4 terms, my brain immediately jumps to grouping. So I want you to factor this by grouping, all right? And then come back and see what happens next. All right, so at this point I have factored by grouping. If you didn't get those factors, I would pause the video right now. Otherwise, we're going to move on to changing our h of x to 0, which normally is an f of x. But we're changing that to 0 so we can solve. And then we set each of our factors equal to 0. So 3x squared plus 8 equals 0, and x plus 6 equals 0. And I'm going to do this one first because I just need to subtract 6, and then now I know that x equals negative 6. So that's one of my answers, and I know I need 3 in total. So then over here, I need to subtract my 8 first. 3x squared is going to equal negative 8. And then I'm going to divide by 3. So I get x squared equals negative 8 over 3. And I'm going to leave that as a fraction. Now this squared, I get rid of that by taking the square root. Now we're taking the square root of a negative, so that means we are going to get x equals plus or minus I, that's for that negative in the square root, of the square root of 8/3. So I square root of 8/3. And this is my 2 other answers, positive and negative. So I've got 1, 2, 3 solutions. So I found all my solutions. Awesome. Thank you so much for watching. Catch you next time. Bye.